here we go. Calculus has three big ideas: derivatives, limits, and integrals. We've spent a lot of time talking about these, haven't we? And we'll continue to look at derivatives for the rest of your mathematical career, really, but limits is right now what we want to focus on today. It's going to help us as we talk more about this hidden behavior of curves. Notice that we've been talking about things like this, right? We've been graphing like cubics and things like that. Well, in this situation, as x tends towards infinity, we would say that y tends towards to infinity as well. As the x value gets bigger, so does the y value, okay? And so we want to say what happens as x approaches infinity. Easy to see in that situation. Others, it's more difficult, okay? So here's what I want to show you in these situations. Generally, for a limit, you can just plug in the value. So limit as x approaches a of f of x is f of a. What does that mean? If you have the limit as x approaches, say, 2 of the square root of x plus 7, you know, in order to evaluate that limit, all we really need to do is just plug in 2, and we get 3. Good with that? The problem is that now we're approaching infinity, and note that infinity is not a number because you can't point to it on a number line. Rather, it's an idea for very, 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 very large numbers. Okay? So the limit as x approaches infinity of x to the nth, what happens there? Well, suppose you had the limit as x goes to infinity of, we'll say, x to the 8th. If I plug in a very large number and take it to the 8th power, what are you going to get? Another very large number, right? And so this does approach infinity. Suppose the exponent, instead of being even, suppose the exponent was odd. Limit as x approaches infinity of, say, x to the 9th. Does that change my result? No, it doesn't. Because if you take a very large number and multiply it 9 times, you're going to, again, get another very large number. What's different about this one? Negative infinity. Yeah, negative infinity. So if we take the limit as x approaches negative infinity of, we'll say, x to the 20th, if you take a very large negative number and raise it to the 20th power, what kind of number are you going to get? A positive number. So that would be positive infinity. And if you take the limit as x approaches negative infinity of x, say, to the 31st power, well, if you multiply a negative number an odd number of times, you're going to get a negative number. Any question thus far? All right, what's different about the next two? Fraction. So notice what happens if we plug in a large number for x here, okay? We get 1 over a very, very large number, don't we? Now, to denote a large number, I'm going to use the letter n. Capital N for a very large number, okay? Does it really matter if the degree is positive or if it's odd or even? You're going to get 1 over an extremely large number. What's 1 over an extremely large number going to be going to produce? An extremely small number. So it's going to get close to what? 0. Suppose that it was 1 over a very large negative number. Would everybody agree that you could end up with a positive or a negative, depending on the degree of n? But either way, it's still going to be a very small number, right? So it's going to go to 0. You also have functions that behave a little bit differently. Can somebody describe for me the graph of sine of x? A wave? Does it ever stop making a wave and just like say, creep up like that? That doesn't happen at all, does it? So would you agree with me that if x is tending towards infinity, that the output always stays between +1 and -1, and it never really narrows in on one value? So in this situation, the limit does not exist. And it's hard to show something like that algebraically. It's easier to just kind of look at it and make sense of it via the graph. That one we don't get to cover right now, and it's really kind of sad because it's a really, really nice limit. That is hopefully something we get to do at a later point. We missed out on it just with our crazy year, but we'll get back to that at a different time. There's this one limit can take up like 3 days. But this one we can do. We would have sine of, and if I plug in infinity, I have 1 over a very large number. What is 1 over a very large number? Very small number that's going to approach 0. So we'd have the sine of 0. A for the day. Who can tell me what the sine of 0 is? It is 0. You're just thinking you're at 0 or 1, right? 0 or 1. Do you know how does everybody know how we come up with 0? We've shown you a few times. Again, so we look at 0 degrees, which would be right here. And what is that point right there on the coordinate plane? That is 1, 0. Cosine is the x value. Sine is the y value. That's how we know. Got to go back to that. Okay. All right. So let's try some examples. Part of what I like about these is sometimes you know what the graph looks like. Everybody know what 4x minus 1 looks like? Like that, right? So as x goes towards positive infinity, what's y going to go towards? Positive infinity. So you already know the answer, right? We're going to confirm it algebraically. And here's a great way to do it. I'm going to factor out an x. And you might say, well, Mr. Gantz, you can't really factor out an x. You can. I get x times, what do I get if I factor out an x? 4 minus 1 over x. Everybody okay with that? Now, the idea is we're going to approach infinity. I can't plug in infinity because infinity is it's not a number, it's an idea. So I'm going to use the letter n for a very large number. Get a very large number times 4 minus 1 over a very large number. What's 1 over a very large number? Yeah, it's going to go to 0. So you end up with, so if you see 1 over a very large number, that's probably the most important thing you're going to do today. It just goes away because it becomes 0. So you get 4 times a very large number, which is going to produce a very large number or infinity. And that confirmed with your graph, right? So this one, I know the graph. It's a parabola that goes like that. So as x goes towards infinity, y is going to go towards infinity. I'm going to show it algebraically. Limit as x goes to infinity of, let's factor out the largest term, which is an x squared. When I factor out x squared, what are you left with? Good. So if I plug in a large number, I have a large number squared times 1 minus 3 over a large number. What's going to happen? 3 over the large number is going to go to 0, right? And you get 1 times n squared, which would be a very large number or infinity. The next one, same thing, parabola, right? Except I'm headed towards, as you head towards negative infinity, what's the y value head towards? Positive infinity, right? Let's show that algebraically, a little bit different. When as x goes towards negative infinity, I factor out an x squared, and what are you left with? 10 over x. What happens to the 10 over x? It's going to go towards? Right. So notice I didn't take the time to plug in n because I think you understand what's going on right now, right? If I plug in a very large positive number or a negative number, which I'm plugging in a very large negative number. What do you get when you plug in a very large negative number? Produces a positive. So remember to account for that negative and see what happens if it's positive or negative. Now, that was nice because you knew what all the graphs looked like, right? Well, what if you don't know what the graphs look like? Like this one right here. You don't know what the graph looks like, do you? So, no big deal. Let's let x go towards infinity. And I'm going to factor out x out of the top. And I'm left with 2. I'm also going to factor out x out of the bottom. What are you left with when you factor x out of the bottom? 1 minus 1 over x. Notice what happens because of my factoring. You can cancel off the x's. So you're left with 2 over 1 minus 1 over a very large number. Yeah, this goes to 0. So in this case, you get 2 over 1, which is just 2. Yep. What do you think I should factor out of this one? I'm going to factor an x cubed out of the top. What are you left with? And what do you want to factor out of the bottom? And what are you left with? So x cubed over x squared, what's that going to leave me with? Just an x in the top, right? What's going to happen to 2 over x, the 3 over x squared, the 1 over x squared? Those are all going to go to 0. Am I plugging in a large positive number or am I plugging in a large negative number? A large negative number. So I would get negative 4n in the top, and what would you get in the bottom? 1. What's negative 4 times a very large number? A very large negative number, which will be negative infinity. The next one, I don't factor anything out of the top. What are you going to factor out of the bottom? And you're left with 1 minus 3 over x plus 7 over x squared. The 3 over x and the 7 over x squared, those go away. Are you plugging in a large positive or a large negative? What's going to happen when you square it? Makes it positive, so you end up with 6 over a large positive number, which is going to be 0. Good job. You guys are getting it. We won't have time to finish the notes, but you do have an opportunity to see some other things that are kind of neat. I want you to do the next 3 on your own real quick here. Try the next 3 on your own. Go. I would like to get to the check mark before we're done today. See where we can get. I got 0 for the first one. I got infinity for the next one. You okay with that? Okay. I want to show you something that's interesting that you can anticipate at this point. Right here, if you look, notice how the numerator is the power greater or smaller than the bottom? Smaller. And what'd you come up with? So that means that the top is not getting as big as quickly as the bottom. You see that? It's the same thing with the previous ones that we looked at. You can make kind of an anticipation. Notice here, the top was a smaller degree than the bottom, and you got 0. Notice when the top was bigger than the bottom, we came up with positive or negative infinity, didn't we? So in this situation, as you look here, you can see that this power is greater than the bottom. So you know you're going to get positive or negative infinity in that situation. I'll work it out for you. I factor out an x squared. I'm left with 5 over x squared minus 6 over, I factor out an x, I'm left with 1 minus 3 over x. So in this situation, notice that this goes to 0 and this goes to 0, and that one of the x's cancels. So I'm left with a large negative number, so this will be a large negative number times negative 6 divided by positive 1. Did I catch you on the negative? That was the goal. So be careful with the negative. You can see how it works out, can't you? So I have a negative times a negative. Sure thing, this heads towards positive infinity. Positive infinity. Okay? Two more examples I'd like to do for you. We don't need to do this one. I think you already understand it. But this one right here. Which is greater, the degree in the top or the bottom? They're even, aren't they? And here's what happens when you have even degrees. All you need to look at is the front coefficients for the largest term. Notice I have 4 over 6. I know right away it's going to come out to be 2/3. Yes, thank you. Thank you. Now, I'll show you as we work it out here, but when you have even degrees, you know it's going to come out to be that coefficient over that coefficient. So we have the limit as x goes towards infinity of, I factor out the x, you have 4 minus 1 over x. And then when you factor out an x on the bottom, you're left with 5 over x minus 6. So notice how the x's cancel. 1 over x goes to 0, 5 over x goes to 0, and notice the 4 over negative 6. That's why you could simply just look at those lead coefficients. You get negative 2/3. So this is an AP exam type question. I've seen this before. People would have the limit as x goes towards infinity, and they would have, say, 9x to the 4th minus 6x cubed plus 3x squared minus 2x plus 1. And the bottom, they would have, 10x to the 4th plus 6x to the 9th. Whoops, sorry, 3rd. Plus 4x squared minus 6x plus 1, okay? And try to evaluate that. Looks like a really complicated problem, doesn't it? The answer is 9/10. That's all you have to do. If you want to factor out the x to the 4th, go ahead. But people spend a lot of time looking at those problems on the AP exam when you know exactly what's going to happen. It's a good test to see where you're at. So let's try this last one, and we'll let you kind of get started on your assignment a little bit. Greater degree in the top or bottom? If the degree is greater in the bottom, what's it going to go towards? It's going to go towards 0. We'll show it really quickly. Limit as x goes towards infinity. Out of the top, I'll factor out an x to the 4th. And I'm left with 9 plus, what number is that? A billion. That's a really big number, isn't it? In the bottom, I'll factor out x to the 5th. And I'm left with 1 minus 1 billion over x to the 4th. X to the 5th. I mean, is that really going to go to 0? I mean, we've had numbers up here before like 6 or 12. Now we've got a billion. Like, is that really going to go to 0? But a billion's really big. It doesn't compare at all to infinity, does it? Like, if you plugged in, 100 billions and took that to the fourth power, you can see how it would just wipe this away and make it 0. And 0 there as well. So you end up with 9 over a very large number, which, as you said, goes towards 0. You won't be able to finish your assignment. We need to pick up a couple pieces. We missed about 15 minutes due to our extraordinary fire drill today. But you have at least the opportunity to get started. So take out your assignment, and I'll talk about the problems you can do and can't.